Hello class. Today we are covering section 2.6, prove statements about segments and angles. Turn to page 104 and let's look at the vocabulary. A proof is a logical argument that shows a statement is true. A two-column proof has numbered statements and corresponding reasons that show an argument in a logical order. A theorem is a statement that can be proven, and we will discuss these different types of terms throughout the lesson. Look at your theorems. You have theorem 2.1, congruence of segments, and theorem 2.2, congruence of angles. Notice on the segments we see segments, and on angles we see angles. Everything is the same setup. We're looking at reflexive, symmetric, and transitive. So if you look at both of these theorems, the order that the segments and angles are arranged are alike. If you pay attention to reflexive, notice that your parts that you're looking at are mirror images of each other. It's saying here that segment AB is congruent to segment AB. They mirror each other. So when you think about reflexive, the left side will be identical to the right side. Symmetric, very similar, but notice it is an interchange. Notice that AB is the second part and CD is now the first part. So you're doing an interchange. Notice here on your P, if P then Q, that you have segment AB is congruent to segment CD, and then notice on the Q part, you have segment CD is congruent to segment AB. So they interchange. And we talked about that term interchange. And we know interchange is just you just placing them in the other position. So again, if you look at the symmetric, notice that AB again is placed where CD was, and then CD is placed where the AB was. Okay, so just pay close attention to that. Transitive is just like the law of syllogism. We talked about that towards the beginning of chapter 2, the law of syllogism. If you remember that, we talked about if P then Q, if Q then R. And if you know, we heard the letter Q twice. So on our third line, we said if P then R. So if you look at the transitive property, notice the part that I see twice was segment CD. And if you think about law of syllogism again, this will represent your Q. And this will represent your if P then R statement. And notice that is what this part says here. This is your first row, your second row, and then your answer part. So think back on the law of syllogism, and that's exactly how you would do transitive. Again, if you look at the congruence of angles theorems, then you will notice it's the same thing. On reflexive, I see the exact thing. On symmetric, it had an interchange. And then on transitive, notice I see angle B twice, so I take that part out. And what was left over was angle A is congruent to angle C. Look at the concept summary on page 106. And this is very important because we're going to look into proofs now. So it's very important that you read the concept summary on writing a two-column proof. And there are also different videos out there on YouTube that can kind of help you get a better understanding as how to write proofs. So it is very important that you take time and do the research and really understand how to write a proof. And basically, you're just proving something by writing it out step by step, what you're doing. So you're going through an actual process. Not hard. The main thing I want you to pay attention to is when you are writing a proof, you always start off with the given information. And on the last row, your answer, what you're trying to prove, will always be the last part, the last statement and reasons. Also, if you notice, on the left-hand side, you have your statements. On your right-hand side is your reasoning. So more likely you're going to see your numbers, your variables on the left side, and then on the right side you're going to see the definitions, theorems, properties, all of those different things on the right-hand side. Also, when you're writing proofs, you're going to use everything you know to write the proofs. So you're not limited to just different definitions, proofs, theorems, properties in chapter 2. You'll be looking back at problems in chapter 1. So as we look at proofs, you're going to build on to your vocabulary on what to write down as your reasoning. Very important that you study the information so when you run across a step, you can relate it to a certain vocabulary term or a theorem or a property. Okay, so very important that you study those things constantly so when it's time to do the proofs, you know what to do. Now turn to page 108 and let's look at the skill practice. Number 3 says copy and complete the proof. If you look at the information given, we want to notice that on the left side we have our statements. On the right side you have your reasoning. You have given information, and this is what we're trying to prove. We want to prove that AC is equal to 11. Now, we have a diagram also to help us. So we already know by the segment addition postulate, we know if we add 5 and 6, we should get 11. So this is a fairly easy proof. We're just basically writing out what we know, but we're doing it step by step, and we're writing out our reasons for that. If you look at the statement part and the reasoning, look at number 1. Notice that again, like we said, the first part is going to be the given information. If you look to the statement part, it's going to be basically your numerical, your computation type problems. And here you write your reasons out in words. So the math part is on the left and the definitions, so forth, is on the right. For number 1, I have my given information, and it says is given. On step 2, notice here we said that AC is equal to AB plus BC. And that's by the segment addition postulate. And we talked about that back in chapter 1, segment addition postulate. On step 3, you have AC is equal to 5 plus 6. And I have to figure out what is the reason here. I wrote this down for my statement, but why did I write that down? What's my reason? If you look at 2 to 3, what do you see changed or what happened? So right here, what you see is that where AB is, I plugged in 5, and where BC was, I plugged in 6. So what is that called in math? When I remove and I replace with something else in that same position. And that was the substitution property. So for my step 3, I'm going to write down substitution property, and I'm going to abbreviate a little bit, of equality. And that's one of our theorems we looked at. Okay, that's one of our the information we looked at back on the previous section. So we applied the substitution property of equality. And if you remember what we talked about on the previous step, is that again, your first part will be your given information, and your last step will be the part you're trying to prove. So this part should be super easy. If you look at here where I said prove, it says AC equal 11. So all I'm going to do on step 4 under reason is write AC equal 11, because that was what I was trying to prove. And for that reason, they said I just simplified. Again, we know 5 plus 6 equals 11, and the only reason for that is that we simplified those together. Look at number 4. It says, which property listed is the reason for the last step of the proof? Now we look at our proof, notice that we have everything set up except the very last reason. Again, if you notice on the first row, you have the given information. You always start off with the given information. On the next step, we notice that 59 degrees equals the measure of angle 2. And the reason for that is the symmetric property of equality. And when you think about symmetric property, notice it is an interchange. Notice where the 59 degrees was moved to, and notice where the measure of angle 2 was moved to. So that is symmetric property. It did an interchange. On the last step, we're trying to figure out what is the reason. Now, we can look at this. It says the measure of angle 1 is equal to the measure of angle 2. So if I go down my list, off the top, we know it's not distributive property because we know the definition of distributive property. So it doesn't like distributive property in any kind of way. Reflexive property is a mirror image. And if you look at number 3, it is not a mirror image. It does not say the measure of angle 1 equal to measure of angle 1 again. So it's not reflexive. Symmetric is an interchange. So if you look at from step 2 to step 3, it did not do an interchange. 59 has not moved down to the third step, so it can't be symmetric. So the only answer it can be is transitive. But we need to know why is it transitive before we conclude that it's transitive. To look at transitive, we want to rewrite steps 1 and 2 so we can see the transitive property of equality. So if I rewrite this, and you want to think back to your theorem and look at that as well to help you. But if I rewrite this and I said if the measure of angle 1 is 59 degrees and 59 degrees equals the measure of angle 2, then the measure of angle 1 equals the measure of angle 2. Now, you think about transitive property, and remember we said it's very similar to our law of syllogism. This will be your first row, you got your second row, and now you have your answer part. If you look at the very first part, you have the if P, your P part. Okay? Which part do I see twice? And the part I see twice, I want to cancel out. If I look at this part, I see 59 degrees twice. So I want to cross that out. When I cross that out, we want to write down what is left over again. So if we write down what's left over, I have the measure of angle 1 is equal to the measure of angle 2. So for part 3, under statement, the measure of angle 1 equals the measure of angle 2 by the transitive property of equality. Again, whatever we see twice, we take away and we write what's left over. And that's going to give us the transitive property. On that particular problem, it was hard to see it. But you have to take time and rearrange the way something is written. As long as you're not changing the true value of it, you can't rearrange. So as long as you're rearranging it a little bit, you can see that that was a transitive property. Look at numbers 5 through 7. It says use the property to copy and complete the statement. Number 5, you have the reflexive property of congruence. Reflexive is a mirror image. So for number 5, my answer would be segment SE Again, it's congruent to segment SE, and they mirror each other. Look at number 6, symmetric property of congruence. Remember symmetric property, it is an interchange. So if I do an interchange, angle JKL will be in my first blank, and angle RST will be in the second blank. So that way I can see the interchange. Number 6, my answers would be angle JKL and then angle RST. And we want to make sure we write it in that order. Look at number 7. The first thing you want to pay attention to when you're looking at the transitive property of congruence is you want to identify the different parts. And again, it's similar to my law of syllogism. It's very similar. So if we understand law of syllogism, we talked about P, Q, and R. And we remember that whatever we see twice, we take out. And we have my answer, which is if P, then R. So if you look at my answer part, this is my P and this is my R. So this is my P and then this is my Q. So if you remember, we said if P, then Q, if Q, then R. So my Q should be angle J, and then my R should be angle L. So let's go over that again. We said if P, then Q, if Q, then R, then we have if P, then R. Okay? All right, so you want to make sure you pay close attention to that. Notice here, the angle J is the part that went away, and we were left with angle F and angle L. Let's look at numbers 9 and 11. It says, name the property illustrated by the statement. Looking at number 9, I have angle VWX is congruent to angle VWX. So we want to figure out what property applies to 9. And if you notice, they are mirror images of each other. So the statement that talks about a mirror image of each other is the reflexive property of congruence. Look at number 11. 11 is a little tricky. You have YZ equal ZY. So it is very tricky. Is it symmetric or would it be reflexive? Now we know that we think about symmetric, it's an interchange, but this is not the case. When you do the interchange, you're going across the equal sign or you're going across the congruent sign. If you look at 11, notice that I didn't go across the sign. So it's a little different. On this one, it will be still the reflexive property, because if we think about segment lengths, we know that regardless of how we write it, it's still the same segment. So remember back at chapter 1, we talked about segments. If we interchange the way the letters are positioned, it is still the same segment. So this one again is a little tricky, but this will be the reflexive property of equality. And I'm going to abbreviate on this one. Another thing I do want to stress, if you notice on number 9, we said reflexive property of congruence. I see a congruent symbol, so that's why we said congruence. On 11, I see an equal sign, so we say equality. So congruence for congruent signs, equality when we see equal signs. Another thing I want you to pay attention on number 11 is if you look at number 11, it's only one statement there. It's like a if P then Q. If you think about your transitive property, you have like 3 different statements going on. If you look at symmetric property, you have 2 different statements. And reflexive only has 1 statement. So that's another way to determine that this was also reflexive property of equality. Look at 15. You have beach vacation. You are on a vacation at the beach. Along the boardwalk, the bike rentals are halfway between your cottage and the kite shop. The snack shop is halfway between your cottage and the bike rental. The arcade is halfway between the bike rental and the kite shop. And this is basically asking us to make a sketch of the diagram that represents the given information. So if you look at the directions there, it's asking us to make a sketch of the direction of the diagram that represents the information. So if you look at our answer of our sketch for 15, it says along the boardwalk. So along the boardwalk, we want to know, we're thinking about a straight segment here. And again, we have the bike rentals are halfway between the cottage and the kite shop. So notice I have it between the cottage and the kite shop is halfway. So we know halfway meaning midpoint. It says the snack shop is halfway between the cottage and the bike rental. So again, we're talking about another midpoint here. So between the cottage and bike rental, we have the snack shop, which is our midpoint. And then it says the arcade is halfway between the bike rental and kite shop. So again, we have the arcade as being a midpoint of the bike rental and kite shop. So when you think about halfway, we want to think about our segments and midpoints. Number 17 says solve for X using the given information. Explain your steps. Now 17 is looking at a proof again, but it's more detailed. I want you to go to the back of your book for number 17, and I want you to write down the way they set up this particular problem, and I want you to also understand how they got each answer. The only part that should be tricky is the second step where it says transitive property of congruent segments. But other than that, it should be super easy. The first step is given. The second step talks about transitive property. And then the third, fourth, fifth, and sixth step is just basically solving for X. And it's give you the different properties that tells you what steps to do. When we solve an equation, we already know those different properties. We know about addition property, subtraction property, division property, distributive property. We know about all these different properties already. So look at 17, write those answers in the back, and let's go to the next one. Number 21 says, in the bridge, in the illustration, it is known that angle 2 is congruent to angle 3, and ray TV bisects angle UTW. Copy and complete the proof to show that angle 1 is congruent to angle 3. Now, as I'm reading this statement, I see 3 different things. I see angle 1, angle 2, and I see angle 3 twice. So off the top, I should know that transitive property is going to be somewhere in my answer. The word bisect. Okay, you have to know what that word means. We know bisect means that it basically takes those 2 angles and make them 2 equal parts. So we know that the word bisect makes angle 1 and angle 2 equal to each other. So let's look at the given information. So we have statements and reason. Notice I wrote down that it has in the information that Ray TV bisects angle UTW, and that was given. Always start your first row with the given information. Last row will be your answer. Step 2. So we want to, like I said, we want to think about transitive property, because more than likely that's what we're going to be looking at is transitive property. If you look at step 3, I'm going to look at step 3 also. So step 3 says angle 2 is congruent to angle 3, and that's given information. Now we talked about the word bisect. So if I look at step 2, I have angle 1 is congruent to angle 2, and I know that they're congruent because they bisect each other. But I have to write down, what do I use? I have to use a definition. So you think back at your definitions. For number 2, my answer would be the definition of angle bisector. Okay, now if we look at step 3, we have angle 2 is congruent to angle 3. If you look at 2 and 3, what do you notice? I have P, Q, Q, R. So if you notice on the 4th step, I have P, R. Notice angle 2 goes away, and I'm left with angle 1 and angle 3. So I know that my answer for step 4 and the reasons is transitive property. So my answer for that is transitive property. And when you're taking notes, it's okay to abbreviate the notes. And then when you're doing homework, classwork, tests, write it all the way out. So for step 4, my answer is transitive property of congruence. Again, I use the term congruence because I see congruent symbols. Look at number 27. It says, in the sculpture shown, angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3. Classify the triangle and justify your answer. If I look at the information, again, I see 3 different things. I see angle 1, angle 2, and angle 3. Notice I see angle 2 twice. So is it reflexive, symmetric, or transitive? So if I think about that, it is going to be transitive property. If it's transitive property, that means that all 3 angles are congruent. So what type of triangle would this be? It will be equal angular. So my answer for 27 is, it is equal angular. And we want to remember what equal angular means. That means that all the angles are congruent. And we know it's equal angular by transitive property. Of congruent angles. So I know that it is equal angular by transitive property of congruent angles, because we know that by transitive property, angle 1 will be congruent to angle 3. Okay, check your Edmodo for any other additional work.